Hi everyone, I'm Caroline and today I will deliver the materials for cost accounting tutorial from week 3. Here's the outline of today's session. We are gonna learn two topics which are linear cost function and cost estimation using quantitative analysis. That consists of regression analysis, halo method, and also the evaluation criteria. Before we jump to the first topic, we need to understand first what is cost driver. So cost driver is the unit of an activity that causes the changes in activity's cost. For example, cost driver would be like number of hours machine used, number of unit produced, or working hours of the labor. So as we learned before, there is two types of cost, which is variable and fixed cost. For the variable, you can see it in panel A. It shows the relation between CPU hour use and the total cost. Here is CPU hour is the cost driver because it's affected the total cost. So by the illustration, the total cost is $0.5 per CPU hour use. So we will get the function here is y equal $0.5 times x. When we put the number here, so for the x or CPU hour use, we put 4,000. So we'll resulting the total cost of 2,000. Moving on to panel B for the fixed cost. The graph show how fixed costs work, where the total costs remain constant no matter how much the CPU hour use. So the function will equal to constant, which is $1,000. And for the third panel, it shows mixed costs that combine variable and fixed costs. So for example, the total cost would be $300 per month plus 20 cents per CPU hour use. So for the function, it will be combine the variable and fixed cost, which is y is the total cost equal $300 is the fixed cost plus $0.2 times x, which is the CPU hour use, as the variable cost. And we will learn further about the mixed cost for today's session. By identifying the cost driver and calculating the cost, it will help the manager to estimate the cost for a project and will help them for the decision-making process in the future. So there are 6 steps here to estimate the cost. The first one is to choose the dependent variable. As seen in the table, the dependent one is indirect manufacturing labor cost because the cost is dependable to other variable. And the second step is to identify the independent variable or cost driver. So here is the machine hour as the cost driver. Next, we need to collect the data on the dependent variable and the cost driver. For the step 3, we already had the data for week 1 to 12, also the dependent variable and the cost driver. So we can continue to step 4 in plotting the data. So basically, we move the data from the table to the graph. As seen here, for the point number 1 or week 1 is when the machine hour is 68 and the indirect manufacturing labor cost is 1,190. Next is the step 5 is to estimate the cost function. So the first method is the regression analysis. It is a statistical method that measures the average amount of change in the dependent variable associated with a unit change in independent variable. As we can see, this is the data plot that we have before. Then we make the regression line which is the average amount of change in the dependent variable and independent variable. We usually use Excel to help us making the regression line. So this is the second method that we can use for estimate the cost, is by using the high-low method. We have this basic function, which is y equals a plus bx, and referring to our previous table, the first step that we need to do is to find the highest cost driver. Here is the cost driver, is in week 6, which is 96 machine hour. And next we need to find the lowest cost driver, which in week 8 with 14.6 machine hour. Then we will find the difference between the highest and the lowest cost driver, which is 50, and we need to find the difference for the dependent variable also, which we get $746. Next we will find the coefficient B, or slope coefficient, by dividing the difference of dependent variable with the difference of the cost driver. Here we got $746 divided by 50 machine hour, and we got the B for $14.92 per machine hour. Next we need to find the A. So basically we just switch position to make it more easier for us to do the calculation. So we're gonna put the highest or lowest data. Here we put the highest one as the indirect manufacturing labor cost, or Y, minus the B times the cost driver, or X, and we will get the A for $23.68. After we get the A and B, we can put it in the basic function, and we will get the cost function to the estimated cost. Next step, and the last step, is to evaluate the cost driver of the estimated cost function. We have 3 criteria here. The first one is economic plausibility, where show the relationship that when the cost driver is increasing, the dependent variable will also increase. The second one is goodness of fit. It is the vertical difference between actual cost and predicted cost, or the regression line. So if the gap is small or short, it indicates that the dependent and independent variable are related. And for the third one is significance of the independent variable, where if a flat or slightly sloped regression line will indicate that the relationship between cost driver and the dependent variable is weak. And if the regression line is quite steep, it will show that the relationship between the cost driver and the dependent variable is strong. Yeah, so that's all for the materials. Let's try the exercises.